The history of diamond. The first diamond discovered in India in the 4th century. Ancient civilizations believed diamonds were gifts from the gods and that they would bring health, wealth, and strength. Since then, we have learned the science of diamond formation, yet we continue to entrust diamond with similar ideologies. As the Earth was cooling from its violent cosmic beginning, as a molten planet, intense pressure and heat created the diamond we continue to extract today. As we journey back in time, you will discover how these precious stones that adorn your finest jewelry were made. Diamond can be made in multiple ways. You may not have known, but before we move on, let's learn diamond formed from coal or not. Many people believe that diamond is formed from the metamorphism of coal. That idea continues to be the "how diamonds form" story in many science classrooms. Coal has rarely, if ever, played a role in the formation of diamonds. In fact, most diamonds that have been dated are much older than Earth's first land plants, the source material of coal. That alone should be enough evidence to shut down the idea that Earth's diamond deposits were formed from coal. Another problem with the idea is that coal seams are sedimentary rocks that usually occur as horizontal or nearly horizontal rock units. However, the source rocks of diamonds are vertical pipes filled with igneous rocks. Rest of this video I will show you the most convincing evidence that diamond doesn't belong to coal. So, how does diamond made? Diamond formation in Earth's mantle. Geologists believe that the diamonds in all of Earth's commercial diamond deposits were formed in the mantle and delivered to the surface by deep source volcanic eruptions. These eruptions produce the kimberlite and lamproite pipes that are sought after by diamond prospectors. Most of these pipes do not contain diamond or contain such a small amount of diamond that they are not of commercial interest. However, open pit and underground mines are developed in these pipes when they contain adequate diamonds for profitable mining. Diamonds have also been weathered and eroded from some of these pipes. Those diamonds are now contained in the sedimentary deposits of streams and coastlines. The formation of natural diamonds requires very high temperatures and pressures. These conditions occur in limited zones of Earth's mantle about 90 miles or 150 kilometers or more below the surface, where temperatures are at least 2,000 degrees Fahrenheit or 1,050 degrees Celsius. The critical temperature pressure environment for diamond formation and stability is not present globally. Instead, it is thought to be present primarily in the mantle beneath the stable interiors of continental plates. Diamonds formed and stored in these diamond stability zones are delivered to Earth's surface during deep source volcanic eruptions. These eruptions tear out pieces of the mantle and carry them rapidly to the surface. Volcanic eruption is extremely rare and has never been observed by modern humans. Diamond formation in subduction zones. Tiny diamonds have been found in rocks that are thought to have been subducted deep into the mantle by plate tectonic processes, then returned to the surface. Diamond formation in a subducting plate might occur as little as 50 miles or 80 kilometers below the surface and at temperatures as low as 390 degrees Fahrenheit or 200 degrees centigrade. In another study, diamonds from Brazil were found to contain tiny mineral inclusions consistent with the mineralogy of oceanic crust. Others have inclusions that suggest that subducted seawater was involved in their formation. A more recent study investigated the origin on blue boron containing diamonds that formed at depths as great as 400 miles or 650 kilometers. These super deep diamonds also contained inclusions indicating that they were derived from subducted oceanic crust. Diamond formation at impact sites. Throughout its history, Earth has been repeatedly hit by large asteroids. When these asteroids strike the Earth, extreme temperatures and pressures are produced. For example, when a 6-mile or 10-kilometer wide asteroid strikes the Earth, it can be traveling at up to 9 to 12 miles per second, or 15 to 20 kilometers per second. Upon impact, this hypervelocity object would produce an energy burst equivalent to many nuclear weapons, and temperatures hotter than the sun's surface. The high temperature and pressure conditions of such an impact are more than adequate to form diamonds. This theory of diamond formation has been supported by the discovery of tiny diamonds around several asteroid impact sites. Tiny, sub-millimeter diamonds have been found at Meteor Crater in Arizona. Polycrystalline, industrial diamonds up to 13 millimeters in size have been found at the Popygai crater in northern Siberia, Russia. Formation in space. NASA researchers have detected large numbers of nanodiamonds in some meteorites. Nanodiamonds are diamonds that are a few nanometers, billionths of a meter in diameter. About 3% of the carbon in these meteorites is contained in the form of nanodiamonds. These diamonds are too small for use as gems or industrial abrasives. However, they are a source of diamond material. Smithsonian researchers also found large numbers of tiny diamonds when they were cutting a sample from the Allen Hills meteorite. These diamonds in meteorites are thought to have formed in space through high-speed collisions, similar to how diamonds form on Earth at impact sites. Diamond formation on Earth's surface. In the 1950s, new methods of diamond formation were discovered on Earth's surface. Scientists were able to create the temperature and pressure conditions needed to create diamonds in a lab. Most of the early diamonds were not gem quality, but they were perfect for use as abrasive granules in drill bits, cutting tools, and grinding wheels. Soon larger lab-grown diamonds were being manufactured for use as wear-resistant bearings, heat sinks for computer processors, and high-temperature windows. Today, almost all of the diamonds used in industrial processes are lab-created diamonds. They are also being made in high enough qualities to earn colorless and very slightly included grades from diamond grading labs. They are made in a spectrum of colors by adding nitrogen, or yellow, or boron, or blue to the diamond-forming environment. Green, pink, orange, and other colors are possible with post-growth treatment processes. Lab-created diamonds are being made in the United States and several other countries. China is the leading country producing lab-created diamonds. All lab-grown diamonds are made using equipment that consumes an enormous amount of electricity, which is needed to create the temperature and pressure conditions necessary to grow diamonds. Some of that electricity is likely to be generated from burning coal. These might be the best examples of diamonds being made using coal. The most convincing evidence that coal did not play a role in the formation of most diamonds are a comparison between the age of Earth's diamonds and the age of the earliest land plants. Most of the rock-hosted diamond deposits that have been found were formed during the Precambrian era on the span of time between Earth's formation, or about 4,600 million years ago, and the start of the Cambrian period, about 542 million years ago. In contrast, the earliest land plants did not appear on Earth until about 450 million years ago, nearly 100 million years after the formation of the vast majority of diamonds that have been mined. Since coal is formed from terrestrial plant debris, and the oldest land plants are younger than almost every diamond that has ever been dated, it is easy to conclude that coal did not play a significant role in the formation of Earth's natural diamonds.